For Lab 5 Example 3, we're gonna use a master device transmitting an ASCII character to the slave device, and then the slave device will show whatever it's receiving from the master on the COM port using UART. The master will also have an LED that will be an indicator of every time that the message or the data has been sent. So this one is going to be sending a U character or whatever. Every time that it sends something, it's going to blink the LED. And the receiver Arduino, it's going to show it using the COM port. So let's first go over the master code. We have to include first our library. This library is pi.h. As I mentioned in the lecture, you don't have to install anything, it's already in Arduino, so just include it. Then we can define our LED as pin number 2, which is the one that we're using there. So let's use number 2. In my setup, I need to put my device in master mode. So trail that begin. Then detail right. Slave select, just pins in as high. And SPI begin. And let's make our LED in output mode. So pin mode, LED, output. So this is just to prepare everything. First, we're gonna use the, well, actually we don't need the serial console, so never mind. That's in the slave device. We just want to transmit and print that, turn on an LED. So we don't need that. We're just having our Arduino with SPI begin, and it's going to be transmitting data in master mode. So now let's go to our loop and just send that data constantly. So first we need to go to low for the slave selection. So it's going to be detail right, and then slave select, which is pin 10 as low, to start communication with the slave device. Then SPI transfer, just start sending data, and we're gonna send a U character, capital case. Then we're gonna use our same XOR trick that I showed you in the previous example. So let me do bolt, UN bolt, let's call it blinking equals 0. So we're gonna be XORing that one to blink our LED. So once we transfer, we're gonna do detail right, our LED, and we're gonna use that technique to toggle between high and low. Remember, it's just an XOR. We're XORing 0 XOR 0 is 1, 1 XOR, sorry, 0 XOR 1 is 1, 1 XOR 1 is 0. So every time that it goes through this line, it's gonna make the light to go high. Next time that it goes through here, it's gonna make it go low, and it's gonna be just toggling between high and low. Now we need to stop communication with our slave device, so we need to go high, detail right, SS, high, and let's just use a delay of 1 second, so that we send data every second. So what we're doing here basically is, okay, go down to start communication. We're gonna transfer a U, so the master, it's sending a U to the slave device. We're blinking our LED, then we're going to high to stop communication. And that should be all. So let's upload it. And we should see, oh, that's the wrong Arduino. Let me change it real quick. So let's give it a try again. Let me change my port for Arduino. Good. So now it's blinking every second. That means that it's going through this line and it's sending, every time that you see it turning on or turning off, it means that it's sending a U. So it seems fine. It's time now to program the slave device. For our slave device, we're gonna start with the same library. We need to include that library in my slave device. So include spi.h, then make a char rx equal to 0. We're gonna need to use a flag. You're gonna see the purpose of this. Rx is gonna be used for saving the data that it's been received, and a flag will be used in the interrupt so that we can do something else in the loop. But it's gonna make sense once we're there. So let's start initializing the UART console, 0 begin. Let's use that baud rate, then pin mode, MISO as an output, and all this initialization from here below, it's just to have our Arduino in slave mode for SPI. SPCR. This is for the interrupt. BV. SP. And SPI attach interrupt. So we're gonna make an interrupt that will make the code to jump from the loop to another code that we're gonna write here below. That interrupt will get activated every time that we receive anything from SPI. As soon as we get any data from SPI, the code will be playing here on the loop. It's gonna get interrupted to jump to the interrupt code and do whatever we want it to do in that section. But an interrupt needs to be short. Whatever you do inside of an interrupt needs to be short. You cannot be playing around in your interrupt and write a lot of lines of code. It needs to be fast enough so that it just go there, do critical actions, and get out of there. So the interrupt, you have to write ISR, SPI, STC, vector, and these, it's the code that you need to write. This is what you need to write in order for your Arduino to save data when you receive anything from SPI, since we're attaching interrupts. So let's say that we're receiving something. So we're gonna make Rx, the variable that I declare here in the top, equal to SPDR, which is a register that saves any byte that it's been received through SPI. So this means that I'm receiving something, right? It goes to the interrupt by itself when we receive something. Let's say the master transmit that U, we're in the loop. Arduino is just playing in the loop here around. It receives a U character. It's gonna jump down here, and we're gonna copy that U character into our Rx variable. So Rx is now equal to U or whatever we sent. And here in my loop, what I'm gonna do to not be printing every time, because I mean, if I do serial print and I just print Rx, it's gonna keep printing, imprinting whatever we're receiving. But I just wanted to print once per time that I'm receiving data. So we're gonna have to use a flag. So my flag, it's equal to 0. When I receive something, my flag, it's gonna be equal to 1. And in my loop, I'm gonna check if my flag, it's equal to 1. At that point, I can show what I received. But also, I'm gonna make my flag equal to 0 so that it just shows us, it shows us this. It shows Rx just once. So flag is 0. I'm in my loop. Flag is not 1, so it's just gonna be here looping around. We receive something, doesn't matter what it is. It jumps from here to here. Whatever we receive from SPI gets saved into Rx. My flag is equal to 1. So now this is gonna be true. It's gonna show us what we receive, and then flag is gonna be 0 so that it waits again until we receive something new. And that's basically everything. So let's code it. Good. Okay. Something that I noticed is that my Arduinos are not sharing power, so I'm going to connect power to both of them. So you can see now that my master is blinking because it's sending a 1. Now we can see that in our serial manner. We need to change the baud rate so that it matches the baud rate, and we're receiving U's. So that means that it's actually working. I never programmed this one to print a U. It's just printing whatever it's receiving, and I program the master to send U's. So it actually works. If you play with this code and change this U for whatever you want, that will be shown in the console.